Hi, I'm Trev Luca Spa-Woo. I come from another galaxy, the Star Wars galaxy. I belong to the galaxy of heroes. I belong to a guild. I have main players in my list of characters, including the Rogue One people. Okay, let's get to this point for this next video covering Chapter 14, Aerospace Engineering. We're going to be looking at you understanding the basics of flight and space flight and controls, and maybe the challenges of re-entry. We will see. But I'm going to skip right on down to where do I need to get going with you guys. And that puts us right here. Aerospace engineering applications. So we talked about a lot of theory. Now we're getting into the practical. Okay. So there's two ways to look at it. There's aeronautics and there's astronautics. Astronautics, you tend to think, hey, astronaut, like space, the final frontier. If you've ever watched Swine Trek. Okay. So in looking at aeronautics, guys, again, it could be manned or unmanned craft fly inside the Earth's atmosphere. Okay, that's aeronautics. That would also include things like helicopters, planes that we're familiar with, jets, things like that. Now there are four areas to look at here. There's aerodynamics, there's propulsion, there's stability and control, and materials and structures. Okay. So in looking at aerodynamics, we see it got, okay, so in looking at aerodynamics, we have to look at the airflow around solid objects. Now, it'd be kind of an important thing. Now, aircraft are designed to be aerodynamic for a given function. What do you mean? Well, some aircraft, not all aircraft are designed to be fighter craft. Not all aircraft are designed to be transport craft. Not all aircraft are designed to be carrying many passengers from point A to point B. Okay, so there's different things. Now, of course, your aerodynamic planes tend to fly more efficiently, meaning that they can go faster, they can make turns sharper, maybe they use less fuel. It depends on what the purpose is. And that's where you start to get really interesting stuff there. Okay, so here's an example, 3 aircraft, and they have totally different purposes. Now, if you look at this one here, which looks like a goose, there's the head with a cockpit. Okay, this is an Airbus. This could be a cargo plane. Might be. And now if you look at it, if you look at the pic, all right, you notice how it's rounded. So when it's going through, you're cutting down on that air drag. Okay, that's a pretty important idea. And it's Nils-Holgersson lines. So this is not a prototype. This is flat out, this is an aircraft that is in use today. Over here, this is an experimental craft. Kind of looks a little bit like the A-Wing from the Star Wars fame. I'm just saying. So if you look at that shape of it, it's very different compared to the one up above. And then obviously to the left, this one, this is our, I believe, our F-115 stealth fighter. I don't think it's the stealth bomber. I'm not sure. Now, what's up with all the little corners and nooks and crannies? That's actually meant to deflect radar. That's part of it. It is meant to be stealth, meant to not be detected by enemy ground radar, because if it's detected by enemy ground radar, then they can track the surface-to-air missiles and start launching. And even then, there's extra countermeasures that this thing has. Okay. So again, 3 aircraft, 3 different purposes, 3 different bodies. Just saying. Okay. Yes. So looking at propulsion, the whole purpose of propulsion is creating thrust for movement. Now, of course, they're all using Newton's law. For every action, there's an equal and opposite reaction. So we can look at things like propellers, gas turbine engines, and rocket engines. Gas turbine engines, you could look at those as jets. Okay, and even then, there's some differences with the jets. So your basic one, propeller. The propellers, they do create thrust. They work like rotating wings that spin around a central shaft. Okay, so that is for the regular plane. A helicopter, it's the same idea, except you can actually adjust the angle of the blades. You can actually adjust the angle of attack on the rotor blades themselves, but that's that main one. Now there's a secondary one on the helicopter. If that goes out, then the helicopter is just going to spin like this. Okay? Hey, real world stuff. Just saying. So it produces lift in the same way as the wing, except it's going in the forward direction. Okay? So here's an example of an old World War I biplane. So this is the Spod 13. Okay, and that's the basic propeller that you're seeing there. Now, in World War I, that's where they first started seeing that aircraft were going to be really useful. And there were those guys who predicted in the next war, aircraft is going to be a really big deal. And it turned out it was. The first time that up to that point in World War I, aircraft, they were used basically to go and take pictures of the enemy lines, see where the trenches are and all that. But then things started to get real, okay? The first plane-to-plane combat involved the pilot taking a pistol and start shooting at the other guy. That's when it started. So then they upped the ante by installing machine guns on the front part of the fuselage. And then they ran into another engineering difficulty. Of course, they tested this out before the plane took off. The timing of the propeller and the timing of the firing of the machine guns weren't always mixing at the right point. Wait, Canu, what do you mean? The propeller's spinning, they test fired the machine guns, and the propeller was being shot off. Problem. So they had to go and work the timing of the propeller and the machine guns firing such that when the propeller was not in front of the machine guns, that's when the machine gun could fire. Okay, that was it. But I wanted to show you that this plane was quite real. Okay, and this is the actual plane. That's a model, but I wanted to show you the propeller side of it. Okay, this is a World War I plane flown by the French ace, Georges Guinemer. He did not survive the war, okay, and it was known as the Vieux Charles, or Old Charles, for those of you who are not familiar with the French. You'd say, Canu, why did you pick this? I found out that my grandfather guarded this guy's plane in World War I. He did for a time. And I actually got the confirm from my aunt before she passed away, because I said, that's kind of weird. It's like, and it turned out that, you know, when I asked her about the name, that's when she said the Vieux Charles, because she doesn't know English. Okay, they said the Vieux Charles. It's like, oh my Lady Gaga. So, yeah, my grandfather actually guarded this guy's plane. Okay, so yeah, a little bit of history there. He wasn't the French ace of aces, but he was like the number 2 guy. And he was a nice guy by all accounts, but he didn't survive the war. Sadly, like many guys did not. All right, let's get into gas turbine engines. Think jets. You draw air into the engine front, the intake, and you compress it. Now, in that compressed air, you inject the fuel, then you ignite it. Now you get your explosion, the burning escape, the burning gas gets out through the rear of the engine, and it turns the compressor fan, okay, which again allows the process to keep going, and it creates thrust. So when we look at engines here, the way that you could stop up engines, and this has happened before, if birds get sucked into it, when a jet plane is flying, yes, that has happened. Or if the plane is flying over an area that's very swampy and you got a little tiny bugs in there and there's lots and lots of the bugs that they get sucked up into the jet intake, will it stop the jet engine? Yes, it would. Okay. But I wanted to point out, that's an inherent weakness. Okay. But that's a very rare occurrence. But the idea is really simple. Free air goes in, it gets compressed, it ends up being ignited, the fuel they injected, they ignite it, it explodes, and the exhaust goes out that way. And according to Newton's law, third law of motion, for every action, there's an equal and opposite reaction. So that moves the jet engine forward. Okay, where did it start? Well, kind of started before World War II, but the Germans were really the first ones to come up with ideas on putting the jets actually to use. The Americans, the British, they had their own jets, but they were prototypes, they were designs. The Germans were ahead of the curve. So what you see there, this is the V1 bomb. Okay, the British called it the buzz bomb. Okay. And they would launch those. This was on a one-way trip, and typically they were launching this to London. This was the jet engine here. So what you're seeing there, that's the jet engine, okay? And this whole thing was filled with explosives. So essentially it was an unguided missile, and it would go and it would land in London. And did it hurt people? Yes. Did it do damage to property? Yes. It was meant to be a psychological terror weapon. Basically, Hitler's way of saying to the Brits, I can still hit you. All right. But as times changed, the war was changing. The fortunes were going really badly for the Germans. They developed other things. Now, this is a diagram of it. This is an actual picture of these guys getting the buzz bomb ready to go. Now, actually, the Me-262 was one of the first German jet fighters to go out. And they have used it when they went out there. It was successful. However, the time that it could spend up in the air was like less than 10 minutes. And you had to be a really good pilot in order to fly it, take off, fly, fight, and land. Because not all of them were successful at landing the aircraft. Okay. So there's a couple of more of those, okay? So the Arado 234 Blitz was actually the first German jet bomber that they had invented. It saw a little bit of use, but that was about it. The Heinkel 162 was used in February 1945. Now, considering Victory in Europe Day was May the 8th of this year, okay? Had a few months of service. But this absolutely freaked out the Allied pilots because even the Mustang fighters, which were the fastest ones that we had, weren't cutting the mustard. These guys, these jet fighters could go and do things to our bombers. And it terrified our bomber guys, but it wasn't going to change the war. It really wasn't at that point. But still, this technology was there. And with that, we took advantage of that. Certainly by the end of the war, we captured a lot of this stuff, captured a number of the scientists as well. And that has led to some major technological advancements. There's still other designs that the Germans had as prototypes. I don't have those here, but these guys were going ahead of the curve compared to the United States and Britain and Russia at that time. Rockets. Okay, rocket engines. So we use those on high-speed aircraft and spacecraft. Really, you have the fuel, but you have an oxygen mixed in with the fuel. How come? Well, the fuel needs the oxygen in order to burn, okay, in order to ignite. If it's in space, we need that oxygen in there so that it actually has something to combust with. On the planet, on the ground, when it's taking off, having that extra oxygen there compared to, I'm just sucking the O2 out of the atmosphere, it made the rockets burn hot, quick, because you need a lot of thrust to escape the pull of the Earth's gravity. Okay? So the fuel oxygen mix then explode in the combustion chamber. The exhaust is forced out through the nozzle in one direction, the rocket is forced in the other direction. It's kind of like a jet engine. Looking at Newton's third law of motion again. For every action, there's an equal and opposite reaction. Okay? So, again, comparing World War II, the Germans did develop something called the V2 rocket. This is from a film footage of a rocket that was being launched. Were they successful with it? There was some success with the V2 rocket. They were able to send it up very high into the atmosphere and not quite into space. They did get, it was there for like a few minutes and then it came back down. Many of the rockets crashed. Some of them didn't get off the landing pad. There's old footage out there if you look for the V2 rockets. But the thing was, the few that actually did reach England, oh man, it was painful. As these rockets were also packed with explosives. Ouch. Yeah. Now, I want to point out something too. If you look at the general shape of the rocket, we also captured some of those. We also captured some of the scientists. That's what helped our NASA program be able to develop rockets like you see on the Saturn V here going on a moon launch. That was made possible by the guys who developed this. I'm just saying, but wait, weren't those guys Nazis? Some were not. Okay, but the fact was that they were kept for their talents. Okay, these guys are scientists and engineers, and thus Britain used them, the Russians used them, the Americans used them. Especially at the end of the war. Hey, but this is all fact. You can check this. All right. So as we're going through, we got to look at stability and control on a plane, okay? We talked about the yaw, the pitch, and the roll. And if you look here on the different parts of the airplane, okay, you look at this chart here, you got the aileron, the elevator, also known as the stabilator, and the rudder. And what airplane movement does it control? And then it talks about the axis of rotation. And again, what kind of type of stability are you dealing with here? So how the airplane reacts to the controls of the pilot. You have the wings, but you also have the control. Now, there are some like gliders. Gliders get towed up into the air by another plane. They release the cable, and then the person basically glides in the glider. They have controls like they've got the aileron, the elevator, and the rudder. They just rely on gliding as opposed to an engine that's actually making them move. They're just gliding, okay? And you have to be careful about that too because you want to land safely on flat land. That would be a good idea. How about wing design? Looking at wing design, there's different purposes for the wing design. Producing lift would be a big one. But there's also different types of design, and that's what I wanted to show you guys. Okay, so if you look at these here, again, pretty much straightforward. These planes here, very straight, as opposed to if you look at this one here, this is a delta wing, and if you look, you see the triangle delta there. And here is the swept back wings, okay, that's for your modern military fighters. Okay, and little quick history note there. In World War II, the Pacific, where the U.S. is now in the war, and the Japanese had a fighter plane called the Zero. And we had planes called like the Wildcat and the Hellcat and whatnot. And the thing was, the differences between the planes and their design. The Japanese planes were designed on wood and canvas, whereas our planes were designed with metal. Now, what were the advantages? For the Japanese, those planes were much more, their Zeros were very maneuverable. They could turn fairly easily. They could dodge more easily. Whereas the American planes, it was kind of like flying a log. So at the beginning of the war, the Japanese were having an advantage on that. They had a better designed aircraft. The advantage that the US had at the beginning of the war was that our planes could take a lot more bullets before the plane would actually go down compared to the Japanese Zero. Also, the thing about the Japanese Zero that the American planes were more capable of, they were more capable of pulling in sharper, faster turns. Whereas for the Japanese, if you tried to do the exact same maneuver, the wings would literally rip right off the aircraft. So when you're looking at the design of an airplane, yeah, those little details happen and those little details get taken into account. So that's when you're talking about real life, when you're talking about real application, okay, this is just textbook. This is what has actually been documented. So is there a difference about these wing designs? Absolutely. They all have something different. Okay, now I want you to take a look at this one here while I think about it. The P-51 Mustang, I'll talk about that at, I don't know if I'm going to be talking about it this time around. Let me see. Do I? Yeah, I do actually. I get to talk about them on my last slide. So those are your basic wing types that are there. Now, if you look head on, you kind of notice how the wings are placed on the aircraft. You got the dihedral angle. Now that actually increases plane stability. But what is this dihedral angle? Okay, and you can take a look here exactly what that is. It is the angle from the, okay, try that again. Dihedral angles. It's the upward angle from the horizontal of the wings or tailplane of a fixed wing aircraft. Fixed wing aircraft is your regular jet plane, your regular propeller plane that everybody's familiar with. Rotary wing aircraft applies to helicopters because essentially their propellers, those are the wings of the aircraft. So you can look at the differences here. And again, this is designs. Everything has their pluses and minuses on this. Okay. Control, the fuselage, the flaps, the ailerons, the rudder, the elevators, and the control yaw, the pitch. All those things are important when you're looking at your basic plane, when you're looking at your basic plane design. Okay? And again, it's like car design. Everybody, there are those guys who believe that they can develop a better car, and that's what they do with planes. Same idea. Okay? We're almost winding down here. All right. So when we look at structures and materials, the lighter aircraft are more efficient, which is true. They burn less fuel. They cost less to operate. Okay. Fuel, maintenance. They also create less pollution because you don't need such a heavy engine to put out that much thrust. Now, at that point, aluminum was the preferred material. In fact, that's what you're seeing here. This is a P-51 Mustang aircraft. Okay. Although the reality is the composites, which is a combination of different materials to form an alloy, they are gaining more popularity, like carbon fiber, composites, okay, fighter jets. They need to have that because they need to have the strength of the alloy, they need to have the strength of the metal and the toughness, the durability of it to withstand combat conditions. Now, I wanted to mention about that Mustang right there because one of the hobbies that people who are fairly well off, some of them, I mean, they can afford this, they will take the P-51 Mustangs and then they race with them, okay? And in the case of one individual, I think it was about a year or two ago, he was at an air show, he was participating in a race, and the plane just went and nosedived and crashed into the ground, and the guy was killed instantly. There was no way out of it. So, of course, the thing was, well, wait a minute, he keeps his plane in tip-top shape, and all that. So what's up? Well, it turned out that the guy modified the plane. He modified the wings. In fact, what he did, he took the wings and he shortened them a little bit. Okay, I don't know how much. I think it was like 12 inches off each side of the wing. Okay, so instead of having he had a wingspan that was shorter. Well, the problem with something like that you run into is that the aircraft wasn't designed to have a shorter wingspan because his purpose by shortening the wingspan was somehow he could acquire more speed and maneuverability, but that turned out not to be the case. It had deadly results. Okay, so when you have aircraft like that, old aircraft like that, you really shouldn't be modifying them because they were designed at that time for a specific purpose, which was warfare. Okay, and peacetime use, that's fine. There's nothing wrong with it. But when you are messing around with the original design, it can have deadly consequences. Again, engineering in the real world. Hey, Trev Lucas, Spa Woo, I'm winding this thing down here. So we talked about structure and materials in planes. We talked about wing design. We talked about controls. Okay. We talked about stability. We also talked about engine types like rocket engines, for example. We looked at the historical aspects of it. We looked at jet engines as well. Okay. We also looked at propeller systems as well. So all these propulsion systems that we create for forward movement. Okay. We also looked at the type of bodies that aircraft can have. And again, the bodies, they serve a different purpose. That's the point. Okay. We also looked a little bit at aeronautics. Okay. That's the big picture. We looked at aeronautics. Okay. And then there's astronautics as well, which we're going to get into a little bit later on. And with that, ladies and gentlemen, this concludes the third in a series of Chapter 14, Aerospace Engineering. Hey, I hope you got something out of it. It's been fun. I want to say thanks to Mr. Canu. Greatly appreciate it. And with that, ladies and gentlemen, this is Trev Lucas, Spa Woo, Star Wars, Galaxy of Heroes owner, signing off.